logarithms. Okay. Logarithms. This is a subject today. Okay. Let's say we have there is a number. Let's consider a number 16. So the 16 can be written as 4 into 4, and this can be written as 4 square. 4 2 times, so 4 square. Now, when we take logarithm, we say logarithm of 16 to the base 4 is 2. This means that now there are many components involved here. This particular part is the exponent part. This is the exponent here. This is the exponent. This 2 is the exponent. And this is the exponent 2. And another thing is the base 4. This is the base. This is called base. Okay. Now, what does this statement mean? This means that this base 4 has to be raised to a particular number to get 16. That number is 2. And that's why we say log 16 is 2. Okay? Let's take another example. Let's take number 8. Say number 8. Now we're changing number 8. Now number 8 can be written as 2 times 2 power 3. 2 cube is 8. Now we can say logarithm of 8 to the base 2 is the exponent 3. Okay. In general, suppose there is a number n equal to b raised to x, then log n to the base b equals x. So this is the definition of logarithm. So logarithm output basically gives you an exponent. This means that this number b has to be raised to x to get this number n. That is the meaning of it. Now, if this is the given statement, then after taking logarithm, you get this statement. Now, this can be reversed as well. Suppose you are given a statement like log 16 to the base 4 equal to 2, then we should be able to write this base 4 power the logarithm value equal to the number 16. Okay, now let's take another example. Let's take the number 81. Now 81 can be written as many ways. Let's say 81 I'm writing as 9 square. In that case, I take log 81 to the base 9, I get 2, as per the fundamental definition. Now the very same 81, this 81 can be written in another way. 81 is equal to 9 into 9, which equals 3 into 3 into 3 into 3, which equals 3 power 4. So 81 can be written as 3 power 4. That means when we take logarithm on both the sides, you get log 81 to the base 3, you get the exponent 4. Okay. When you see the reverse way, this means that this number's base number 3 has to be raised to a particular number to get this 81. Now, which is this number? This number equal to 4, which is the logarithm value. Okay. Now, let's consider another example of what is the logarithm of, let's take logarithm of 0.0001 to the base 10. This is what we have to compute. This is the question. So in order to compute this, first we have to, what we have to study? First we have to see what is the base. The base we have to study. The base is 10. Now this given number has to be expressed as a power of the base. So the given number is 0.0001. Now this can be written as 1 divided by 1000. 1 divided by 4 zeros. 1 divided by 1, 2, 3, 4. There will be 4 zeros. 1 divided by 10,000. This can be written as 1 divided by 10 to the power 4, or this can be, which is equal to 1 divided by 10 to the power minus 4. Now you take logarithm on both the sides. When you take logarithm on both sides, you get logarithm of 0.0001 equal to the base 10 equal to the exponent. Which is this exponent here? The exponent is minus 4. So this becomes minus 4. Okay. Now you know any number. Now this number is less than 1, hence this logarithm has become negative. Here the logarithm is negative. Logarithm is negative. Now why this logarithm has become negative? Because the number is less than 1. Okay. Now, what happens to the logarithm of a number to its own base? What is the logarithm of 81 to itself? Logarithm of 81 to 81. What is the value? Okay. So based on our fundamental definition, first, how we have to approach this problem? First, there is a given number. This is the number whose logarithm has to be evaluated, and this is the base. So the number has to be expressed. The number has to be expressed in terms of the base. Base power some number. Okay. Now, 81 can be expressed as 81 raised to 1. From this, you take logarithm on both sides. You get log 81 to the base 81 equals to 1. Logarithm of this number to this base equals to this exponent 1. Now this can be generalized that the logarithm of any number a to its own base will always be 1. Okay. Now let's take an example. Let's take consider this equation where we have 32 equals to, we can write 32 as 4 into 8. On factorizing we get this. Okay. Now let's calculate what is the logarithm of this number to the base 2. Logarithm of this number to the base 2. And logarithm of this number to the base 2. Logarithm of this number to the base 2. And what about logarithm of this number to the base 2? Logarithm of this number to the base 2. Okay. So let's start from here. 32. 32 can be written as 32 equal to 2 into 16 equal to 2 into 2 power 4. 2 power 4 equal to 2 power 5. That means log 32 to the base 2 is the exponent 5. Right. So this logarithm, the logarithm on the left side is 5. This is 5. Now what is the logarithm on the right side? What is the logarithm of this number? Logarithm of this number 4. 4 can be written as 2 square. So logarithm of 4 to the base 2 will be 2. So this logarithm is 2. What about 8? 8 can be written as 2 power 3. Now logarithm of 8 to the base 2 will be 3. So this is 3. Now what is the relationship between these two? Is there any relationship? Yeah, the relationship is 5 equals to 2 plus 3. This means that logarithm of logarithm of 32 is equal to logarithm of 4 and logarithm of 8. That means a multiplication problem in logarithm becomes an addition problem. A multiplication problem in number has become an addition problem in logarithm. So logarithm is able to convert a multiplication into an addition. So when you multiply a large number, this property can be utilized. Okay. Now let's find out different logarithmic values of different numbers. So let's start with various numbers and let's make a tabular column of various logarithms. Let's start with 1. Let's start with 2. Let's start with different numbers. Okay. Let's talk about let's consider numbers with base 10. Let's consider numbers with base 10. Okay. So we know logarithm of 10 to the power 1 is 1. And logarithm of 10 square is 2. And logarithm of 10 cube is exponent 3. Here the bases are always 10. This is the base 10. This is to the base 10. And this is to the base 10. Okay, now this logarithm of 10 to the power minus 1 will be minus 1. And logarithm of 10 to the power minus 2 will be, as with the definition, it will be the exponent minus 2. Okay. Now, previously we have learned a property that logarithm of product of two numbers, equal to summation of their logarithm is equal to log A plus log B. This is a very important property. Okay. Another important property is, suppose there is a okay. Now let's calculate different logarithm values of different numbers. For example, let's consider the number, the first number. Let's start with 1, 2, 3, 4, 5, etc. Now logarithm of 1 is always 0. This is the number-end, and this is the logarithm. Logarithm of 1 is always 0. Logarithm of 2, let's define is log 2, and this is log 3. Now, what about logarithm of 4? Logarithm of 4 will be, since 4 is equal to 2 square, we can write logarithm of 4 to the base 2 equal to 2. Or the other way, we can also write when 4 equal to 2 square, we take logarithm on both the sides, log 4 will become log 2 square, and this becomes 2 into log 2. So that means log 4 becomes 2 times log 2. So if we know the value of log 2, then the log 4 can be computed. The log 5, we cannot decompose this because of prime number 5. So let us take it as log 5 itself. Now what about 6? Log 6 can be written as log 2 plus log 3. If you know the value of log 2, then we can substitute here, you get a number. If you know the value of log 3, you can substitute here, you get a number. Now log 2 is already known, then 2 log 2 can be computed. Log 5, if the value has to be given, then we can calculate this. Log 6 is easy to calculate because log 2 and log 3 is known, then log 6 also can be calculated. In this way, if we know the logarithm of all the prime numbers, then logarithm of entire numbers can be derived. Okay. Now, there is a table here. I have provided a table of logarithm against various numbers. So these are the various numbers. Here there is x is provided, so the various numbers are provided. On the other side, its logarithms are provided. Now you see, now let's understand this. Okay, let's take two numbers of let's take a number here. Let's take a number 60. There is a number 60. There is a number 60. Okay. Now this 60 can be written as 30 into 2. 2 into 30. Okay. Now, what is 2 here? This is 2. 2 is here. This is 2. And what is 30? This is 30. Okay. Now here what happens? This 2 multiplies by 30, this 30 multiplied by this 30 gives you the answer 60. So in this side, this is a multiplication. This is multiplication. This is multiplication. Multiply. Okay. Now, what is the relation between the logarithms of these three numbers? Where is log 2? This is log 2. This is the value of log 2. Now, what about log 30? This is the value of log 30. Now, what is the logarithm of 60? This is the value of logarithm of 60. Now, what is the relation between these numbers? This number is 0.301. This is 1.477. On adding these two, you get 1.778151, which is exactly the same as this. That means here, the relationship between these numbers is not a multiplication, whereas it is addition. When you add this number to this number, you get this number. So here, it has become an addition. So a multiplication problem on this side has become an addition problem over here. So if you want to find out the answer to the problem 2 into 30, then you have to find out log 2. You have to find logarithm of this number. You have to find logarithm of this number. You have to find logarithm of this number. You add these two numbers, you get a particular answer. Okay? Now this answer is the logarithm of a number. Now this answer you search here, wherever it matches, you get back here. For example, here, when you add these two logarithms, you search here, you get the number. This is 1.7751. It will match here. This will be the answer. So corresponding number you have to select. And this number will be 60. So this is how a multiplication problem has to be performed using a logarithm. Now, in the present example, these numbers are very small numbers, so without logarithm we can directly multiply. But logarithm will come to handy when the numbers to be multiplied are very large. When you have to multiply very large numbers, then you can use logarithm provided you have a logarithmic table. If you are provided with a logarithmic table, then this multiplication can easily be performed. Okay. Now let's study how the function of logarithm behaves. Let's say there is a function y equal to log x. Y is equal to log x will behave in this way. Now this is a y and this is x. As you give different positive values of x, you get different y values, and y are positive and y is negative as well. Any number greater than 1, logarithm is positive. Any number less than 1, logarithm is negative. Now as the number approaches 0, as x approaches 0, the logarithm shoots to minus infinity. Okay.